The figure shows the trajectory of a particle which is projected from the point O at an angle theta to the horizontal, where tan theta equals to 3/4. This is the diagram. A. Calculate the time taken from O to P. I'm required to calculate the time from O to P. That's the time at P. This is the vertical axis. This is the horizontal axis. The vertical height at P is 1 meter. That's at P, y equals to 1, and the speed U is 10 meters per second. Now let's assume G is 9.8 meters per second squared. You know, the vertical height at any point, and let's say time t, is given by the formula y is equals to u sine theta t minus half gt squared. That means 1 is equals to 10 sine theta t minus half into 9.8 t squared. I don't know sine theta, but from the question, tan theta is 3/4. Let's say a right angle triangle like this, with this angle being theta, then tan theta is opposite all over adjacent. That's 3/4. Now I need to look for the hypotenuse. The hypotenuse can be gotten from the Pythagoras' theorem. The theorem says the hypotenuse squared is equals to 3 squared plus 4 squared. That is the sum of the square of the other side. Now from here, h is equals to the square root of 3 squared is 9, 4 squared is 16. That means the square root of 25. Since 9 plus 16 is 25, that will give hypotenuse as 5. So it means here the hypotenuse is 5. Now sine theta is equals to opposite over hypotenuse. The opposite here is 3. That is 3/5. Now I will substitute the value of sine theta in the equation of the vertical distance. That is 1 is equals to 10 into 3/5 times t minus 9.8/2 times t squared. 5 here 1, 5 here 2 times. 2 times 3 is 6. So it means 1 is equals to 6t minus 9.8/2. That is 4.9 t squared. Now that is 4.9 t squared minus 60 plus 1 equals to 0. The equation gives me a quadratic. I know if I have a quadratic, ax squared plus bx plus c equals to 0. X can be calculated from the formula negative b plus minus square root of b squared minus 4ac all over 2a. Compare this equation to this one. You will see that a is 4.9, b is minus 6, and c is 1. That means c will be equals to negative into negative 6 plus minus square root of negative 6 all squared minus 4 into 4.9 times 1. Since a is 4.9, c is 1 all over 2 into a, which is 4.9. That is, from here, t is equals to 6 plus minus square root of 36. That's minus 6 squared is 36 minus 4 times 4.9, which is 19.6. That is all over 2 times 4.9, which is still 9.8. Here, t is going to have two values. T is equals to 6 plus the square root of 36 minus 19.6 as bracket all over 9.8. That is approximately 1.0 in one decimal place. Or t is equals to 6 minus the square root of 36 minus 19.6 all over 9.8, which is 0.1999. So that is approximating to one decimal place is 0.2. That's 0.2 seconds. Now that there are two times, which one is the correct time from O to P? You know that the maximum height of projection for this projectile is not before P, it's after P. So by observation, it looks like the maximum height can be somewhere here. To know the time which is correct, I will need to calculate the time at the maximum height. So if the time that I've calculated here is more than the time at the maximum height, means that the time is not correct, because P is not after the maximum height, it's before the maximum height. You know, the formula of the time at the maximum height is Tm is equals to U sine theta all over G. That is, the time at the maximum height is 10 sine theta. So sine theta was 3 over 5 all over 9.8. 10 times 3 all over 5, now bracket, divided by 9.8 is approximately 0.6 seconds in 1 decimal place. This is the time at maximum height, 0.6 seconds. But the time at P is supposed to be less than the time at maximum height. The only time among these times that is less than 0.6 is this time, that is 0.2 seconds. So it means the correct time from O to P is 0.2 seconds. So it means this one is not the correct time. So I am back to this question again. The last time I calculated the time at P and I concluded that the time was 0.2 seconds because the time at the maximum height I calculated using this formula, U sine theta over G, and the time was approximately 0.6 seconds. The B part of the equation, I need to calculate the time spent at the height above 1 meter. This is 1 meter, this is 1 meter. So it means I am required to calculate the time from P to Q. Let's say T from P to Q. That's to get the time from P to Q, I need to take the time at Q minus the time at P. So now I will know the time that the particle spent from here to this point. You know, the time at P is 0.2 seconds. The maximum time is 0.6. What will really be the time at Q? You know, to get the time at Q, I will still need to use the equation of vertical height of a projectile. That is, I still need to use this equation, y equals to U sine theta t minus half gt squared. Now, if I want to use this equation here to calculate the time, I will still end up solving a quadratic equation, and that quadratic equation is still going to lead me to this point. Since they are having the same height, 1 meter, 1 meter, I will still come to this place, and when I arrive here, I will still have two times. That's one will be 1.0 seconds and another one will be 0.2 seconds. But now, which time will I choose at Q? In short, I will choose a time that is more than the maximum height. Since the point Q is after the maximum height, the time at the maximum height is 0.6 seconds. So it means among these two times, the one that is bigger than the time at maximum height, that is 0.6, is this one. So I will conclude that this time is the time at Q and this time is the time at P. Now I need to calculate the time spent above 1 meter. As I said earlier, I will take the time at Q minus the time at P. That is, I will have 1.0 minus 0.2. 1 minus 0.2, that is 0.8. Means the time spent above 1 meter is 0.8 seconds as required from the B part of the equation. C, the distance PQ will be equals to, that is, they need the distance from here to Q. That distance is the horizontal distance, and to calculate the horizontal distance of a projectile, the formula x equals to u cos theta t is required, and the time from P to Q is TPQ. That's the time we obtain in B, and let's say this distance from here to here is distance xpq, and the time from P to Q is the time PQ. So it means the distance XPQ will be the speed, which was 10 times cos theta times 0.8. But remember, tan theta was given, and tan theta is opposite all over adjacent. Remember, when I was calculating sin theta, which I obtained from the A part of the equation as 3/5, I know sin theta is opposite over hypotenuse, so I calculated the hypotenuse to be 5. So it means from this triangle, cos theta, which is adjacent over hypotenuse, will be 4/5. So if I substitute 4/5 in this equation, that means XPQ will be 10 times 4/5 times 0.8. 10 times 4 times 0.8, that's 32, divide by 5. Since this was 4/5, that will give me 6.4. So the distance from P to Q is 6.4 meters. For the D part, I need to calculate the maximum height of the particle. The maximum height is given by the formula U sin theta, all that squared, all over 2G. It means that here I'll have 10 times 3/5. That's the value of sin theta calculated from the A part of the equation, all that squared, all over 2 times 9.8. Since I took G to be 9.8, 10 times 3/5 is 6. Now 6 squared is 36. 36 divided by 2 times 9.8 will give me approximately 1.8 meters in one decimal place. So it means the maximum height is 1.8